We are starting with trigonometry, and in trigonometry, we'll be talking about right angle trigonometry, non-right angle trigonometry, bearings, and 3D trigonometry, which is about elevation and depression and the angles related with it. Now, first of all, let us get started with the idea of a right angle trigonometry. Now, when we talk about right angle trigonometry, the very first thing that needs to be done is to draw a right angle. So first of all, that is a base that I've drawn. This is the height and this is the hypotenuse. Now, first of all, let me mark this angle as theta. Let me mark this as 90 degree. The side opposite to 90 degree is hypotenuse. So HYPOTENUSE, if I got the spelling right, this is opposite of 90-degree angle. That's the largest side of a right angle triangle. So that's the first thing. Then we talk about the side opposite to theta. This is called the opposite side. And the side next to theta, this is called the adjacent side. So let me write O for opposite and A for adjacent. Now we will write three trigonometric ratios: sine, cosine, tangent. These are called trigonometric ratios. The value that you get in decimals or fractions, that is ratios. So this is sine, this is cosine, this is tangent. When we talk about sine of an angle theta, that is opposite over adjacent. And let me write the symbol H for hypotenuse. So I'm writing H for hypotenuse. So sine is opposite over adjacent. Cosine of theta, my bad, let me correct it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent of this angle, that is opposite over adjacent. So these are the three ratios that we use. The first one, second one, the third one. What else is there? We have the Pythagoras theorem. So if I apply Pythagoras theorem, this is only applicable to a right angle triangle. So Pythagoras theorem, this is only valid for right angle triangle. You can say that this is a litmus test for a right angle triangle. If it fulfills Pythagoras theorem, it's a right angle, otherwise not. So the biggest side is what? The biggest side is the hypotenuse. So therefore, I'll write hypotenuse square is equals to opposite square plus adjacent square. So biggest side square, that is equals to the base square plus the perpendicular square. By the way, I can have alternative terminology for it, and I can write opposite as perpendicular also. And I can write adjacent as base also. And hypotenuse will still be called a hypotenuse. So therefore, hypotenuse square is equals to opposite square plus adjacent square. That is the Pythagoras theorem. What else is there? What about base into height, or perpendicular or height is also another term. And we can use the formula for area. So I'll write area of a triangle. Area of a triangle, that is a hard and fast formula. That's half into base into height. So now we have all these formulas. What else there is to it? We have something to do with this thing. That is about two angles. They add up to 180 degrees, some trigonometry related with that. So let me write this thing: supplementary angles and trigonometry. Now, you can have your calculator ready. I remember these ratios, so I'll simply write it down. Now let me make different columns. For example, over here, and over here, and over here. Let's say I'm writing 30 degrees and I'm writing 150 degrees. And then over here, 45 degrees and then 135 degrees. And last but not the least, that is 60 degrees and 120 degrees. Now, first of all, if I shift it a little bit to the right, and then also this one over here, this one over here, and let me write over here sine. So let me start with sine. So sine of 30 degrees is 0.5, sine of 150 is 0.5. Sine of 45 in decimals is 0.7071. For 135, this is 0.7071. Sine of 60 is 0.8660, and this is also 0.8660. Now, there is something special about these angles. The first thing, they add up to 180 degrees. That is why the values are exactly the same. 30, the sine, and 150, the sine, that's exactly the same. You can double check, and if your calculator is giving the answer in fractions, that would be 1 over 2, this would be 1 over 2, this is root 2 over 2 in the rationalized form, and this would be root 3 over 2, this would be root 3 over 2. Now, once this is done, let me move to another ratio, that is cosine. And let me talk about cosine. So cosine of 30 degrees is root 3 over 2. Or let me write this thing as 0.8660. This is root 3 over 2. Cosine of 150 is the same, but now it has a negative sign. So this is negative root 3 over 2. What about 45? This is root 2 over 2. This is negative root 2 over 2. And let me just remove these values because that's already given at the top. So this is 0.7071 and negative 0.7071. And this is 0.5 and this is negative 0.5. What do you observe? You observe a negative sign over here, and over here. Now, let me further break it up. This is an acute angle. And this is acute, this is obtuse. This is acute, this is obtuse. This is acute, and this is obtuse. And yes, they are supplementary because they are adding up to, these two are adding up to 180. So yes, they are supplementary of one another, and they are adding up to 180. What do you observe? For acute angle, for sine, acute and obtuse, it's exactly the same. Exactly the same. This is just in the fractional form. For cosine, numerically, it's the same, but for obtuse, this is negative. Acute is positive, obtuse is negative. Acute is positive, obtuse is negative. Now, do you agree with this conclusion? There's nothing to disagree as such, but I'm just making sure that you are on board with me. Just acknowledge it on the WhatsApp. So now what we do is that for sine, I can say versus cosine. So for sine, I'll say that sine of 180 minus theta is the same thing as sine of theta. That's one thing. The other one is cosine of 180 degrees minus theta is the same thing as cosine of theta. That is the conclusion based upon this. If two angles add up to 180 degrees, if one of them is theta, the other one is 180 minus theta. If one of them is 30, the other one is 180 minus 30. If one of them is 45, the other one is 180 minus 45. If one of them is 60, the other one is 180 minus 60. If one of them is theta, the other one is 180 minus theta. So now in this one, I just have to put a negative sign. Why? Because in cosine, The rule is they are numerically the same, but one of them is negative. So if I have negative on both sides, that would be equal. So cosine 180 minus theta is negative cosine theta. Now let me illustrate this using an example. Let's say I draw a line like this. I draw another line like this. So this is 1, 2, 3, 4, and let me draw one more line like this. Now let's see over here. This has a base of 4 units and the height is of 4 units. This base is also of 4 units. This base is also of 4 units. Let me label this thing as A, B, C, and D. Now this angle, let me focus on this angle ACD. Angle ACD is acute, and sine of ACD equals to 4 over 4. Actually 3 over 4. Let me correct myself. This is 3 and this is 4. So this is 3 over 4. So sine of ACD is 3 over 4. Cosine of ACD is 4. My bad, that is tangent I've written. One more thing I have to calculate, that is this thing is 5 over here. Why is this 5? Because this is Pythagoras theorem. AC is the hypotenuse. Therefore, AC whole square is equals to 4 square plus 3 square, which is 16, which is 9, which is 25. Therefore, AC equals to 5 units. So sine is 3 over 5. So sine is 3 over 5. Cosine is 4 over 5. Now, let me look at the angle which is over here, which is BCD. BCD is obtuse. This is the angle that I'm talking about. Now, one other thing is that ACD and BCD, they are supplementary angles. They add up to 180 degrees. Now, without using a calculator, let's say this is a paper 1 question. Can I evaluate sine of BCA? Can I evaluate cosine of BCA? The answer is yes, I can. I'll just take this value 3/5 and write it over here. I'll just take this value 4/5 and write it over here. Since we are dealing with sine, sine of acute, sine of obtuse is the same because they are supplementary. So this is also positive. But cosine of acute, cosine of obtuse, one is positive, one is negative. For acute, it's positive. For obtuse, it is negative. So that is how this basic question is done. And the underlying principle is this thing over here. So that is what I have taught you so far in right angle trigonometry. Now, let me pick a question from here. And this question looks nice. So let me just capture it this way. Okay, this is the first question that I've pasted. Let me keep on pasting 1 or 2 other questions. This is same like that. Okay, let me choose. Okay. Now, let's look at these questions. We will try them out. First of all, just go through the question. It says the diagram shows 3 points A, B, and C. So over here, this is A, this point, and over here, this point is B, and over here, this point is C. Find the length BC. Now, this is a question of distance formula. It can also be done using Pythagoras theorem. So first of all, let me write distance formula. And let me also write Pythagoras theorem. How? I'll just explain it in a short while. The area of triangle ABC, let me mark the base as this. So this is the base. And the height will be marked from here to here. That is the height. So height does not necessarily have to be part of the triangle. So the height is from here to here. What else is there? The value of sine of ABC. And that is something like what we just did. Now, first of all, let me add this green line over here also. Now, if I want to find this thing, which is the distance BC, I can use this as the height, I can use this as the base, and I can apply Pythagoras theorem. So let me get started with the first one. That is the Pythagoras theorem. That is 1, 2, 3, 4, 5, 6. That's the height. 1, 2, 3, 4, 5, 6, 7, 8. That's the base. So first of all, Pythagoras, that is 6 square plus 8 square is equals to BC square. This is 36. This is 64. This is BC square. Therefore, BC is square root of 36 plus 64, which is 100. That comes out to be 10 units. That's the first method of solving this. If you are interested in using the distance formula, the coordinate of B is minus 2, 2. So B is negative 2, 2. C is 6, negative 4. C is 6, negative 4. Therefore, BC, the magnitude, the length of a line, is minus 2 minus 6 whole square. That is x2 minus x1 whole square. And this is y2 minus y1, 2 minus minus 4 whole square, the whole thing under root. So this is negative 8 under root, which is 64, negative positive 6 square, that is 36. 64 plus 36 is 100. Square root of 100 is 10 units. You get the same answer. So this is using distance formula. The other one is using Pythagoras theorem. This thing is done. Area of triangle. 1, 2, 3, 4, 5. That is the base. And the height is 1, 2, 3, 4, 5, 6, 7, 8. So area of triangle is pretty basic. That is equals to part B. That is area is half into 5 into 8. That is half of 40. That comes out to be 20 square units or unit square. So this is 20 over here. The value of sine of ABC. Now this angle over here, let me mark it. That is this green angle or over here. I cannot find it directly because this is a paper 1 question. So therefore, I can find for this purple one, just like what we just did. So let me find the sine of this angle. This is 8 units. This is 6 units. This length is 10 units. For sine, this is the opposite for this angle. And this is the hypotenuse opposite the 90-degree angle. Therefore, sine of this thing is 8 over 10. So let me write this thing as 8 over 10. It can also be simplified and written as 4 over 5. Work in fractions as much as possible. Let me add one other part to it. That is part D. The value of cosine ABC. Now for cosine, I'll be needing this value. This is the adjacent. And the hypotenuse still 10. So cosine would be 6 over 10, which can be written as 3 over 5. Leave the answer in the fractional form. And if it was asked, it will also be for 1 mark. So this is a basic question which people get it wrong because the concepts are not clear. Acknowledge on the WhatsApp if this is all good, all clear. Okay, now let's move on. Now it says in the diagram, BCD is a straight line. So let me highlight this. That is this line, which is BCD. So this is a straight line. And AB is 12. So this one is 12 like this. And what else is there? We have AC as 13. And this thing is 13. Now it says that find tangent BAC. Now tangent of BAC is this one. So let me mark this. This is BAC. This is opposite. And this is hypotenuse. So tangent of BAC is 5 divided by 13. Cosine of ACD. Cosine of ACD is this one over here. So for this angle, cosine is not possible, but it's perfectly possible for this angle over here because that's part of a right angle triangle. So first of all, let me write cosine of ACB. That equals to this. For this angle, this one is the adjacent. And the hypotenuse is what? That is 13. Now let me do one correction over here. This is 12. By mistake, it was written as 13. Tangent is opposite over adjacent. So for this angle, this was the adjacent. This was adjacent, and that was opposite. For this angle, this is opposite. This is adjacent. This is opposite. This is hypotenuse. It's a matter of perspective. So let me just remove the extra plus the colors so that it's not confusing. So now I was talking about this particular angle, and for this is the adjacent, and this is the hypotenuse, and for this angle, this is the opposite side. Since we are dealing with cosine, cosine of ACB is 5 over 13. But we are interested in this one. That is over here, which is ACD. So therefore, cosine of ACD, because this is a straight line, because this line is straight, therefore these two angles are supplementary. Therefore, the rule will apply that the cosine is the same except for the negative sign, which is minus 5 over 30. That's how basic these questions are. Let me solve one more question like this. It says ABCD is a trapezium with AB equals to 21. So let me highlight this. AB is 21. And what else is there? CD is 35. Now this is a parallel side. This is 35. And then it says the two angles are 90 degrees. That we can see. That is this one and this angle. These are 90-degree angle. ACD is theta. Use as much information from the table as is necessary. Calculate AD. So we are interested in finding this. Now let me grab a color. Let me grab a blue color and let me draw a line like this. We are interested in this. Ignore the thickness of the line. Now, first of all, if this is 21 and this is 35, that means from here, let me label this thing as E. From E till C should also be 21 like this. Well, it does not say these two are parallel. Yes, it has to be parallel because it's a trapezium. So this one has to be 21. 35 minus 21 is 14. That goes over here. So now this is it. And what else is there? We are interested, do we have BC? No, we don't have BC. Calculate AD. So what else is there? Hold for a second. AB is 21, CD is 35, and we are related with sine, cos, and tan. So now if we are interested in AD, so AD is like the hypotenuse. So let me highlight this. This red color line, this is the hypotenuse. Now what do we have? We have the base with respect to theta, that is the adjacent. We have the hypotenuse, that is AD, so I'll be needing cosine. So cosine of theta is equals to DE, I have labeled E myself, divided by AD. Cosine of theta is this one, 7/25. That equals to DE, which is 14, and AD is unknown. Therefore, make AD the subject. So AD into 7/25 is equals to 14. Therefore, AD is equals to 14 into 25 divided by 7. So therefore, 7 ones are, 7 twos are, 2 into 25. So AD comes out to be 50 centimeters. That's the answer for this part. So that is how this question is completed. Now, let me have a look if there are more questions which you people can try out. Well, there are some paper 2 questions that also needs to be tried out. So let me look at this and get your calculators ready, because I'll be asking you to use the calculator. So this is a paper 2 exercise. Let me paste this question over here. And let me also paste which exercise are we talking about, because a lot of people, they ask this question, that what's the exercise number and what is this thing. So first of all, let me just grab this thing. And also, which volume are we talking about? So let me first paste this. And over here, I got started with this. So let me add a page over here. And that was a few pages back. Okay, this is page 9. And which volume are we talking about? We are talking about, this is O-level maths, volume 3. So let me also grab this. Trigonometry is over here. And what else is over here? It's all in the table of contents. Trigonometry, geometry, the angle properties that we were doing earlier related to circle theorem, that's over here. We have to do similarity and congruency and rotational symmetry and mensuration with symmetry. This is all left now. So, okay. So first of all, let me write this. So this is the book that we are talking about. Okay. So now let's go back to this. Let me try out this question first, and then we will select more questions. Let me just check if the recording is on. Yes, it is on. Now, let's look at this question. The question says ABC is a triangle. ABC is a triangle in which ABC is 90. That's right over here. BAC is 40. That's 40 over here. BC is 10. And BC is 10. P is the point such that PCB is 20. So PCB, this is 20. Calculate PB, that's one thing. Calculate AP, that is the other thing. Calculate the perimeter. I'll just wait for Azan. So now let me add some colors over here so that we are able to recognize exactly what we are talking about. A red color, a blue color, a green color, that is for this right angle triangle. And then for the bigger right angle triangle, we are talking about this as the hypotenuse. The base is still the same. And this adjacent side with respect to 40 is the orange plus the blue. Now, first of all, they are asking us about PB. Basically, we have to focus on this triangle. So always mention that. We are talking about triangle PBC. And with respect to 20, this is 10 and this is the opposite. So therefore, tangent of 20 degrees, that is PB divided by BC. BC is 10. So therefore, PB equals to 10 multiplied with tangent of 20 degrees. Once you are done with this, then use calculator, not before that. Save your energy, save your calculator battery, save your approximation. That's how we do things. Now, this is a paper 2 question. What about AP? Now, in order to find AP, I cannot find it indirectly. I have to find this whole thing. So for this triangle, this big triangle, with respect to 40, this is the opposite side and this whole thing is the adjacent. So again, a tangent. So let me write over here, I'm talking about triangle ABC. And I'm talking about tangent of 40 degrees. So that is equals to BC, which is 10, divided by AB. Now, AB is AP plus PB, or even better, just simply let me write this thing as AB. So therefore, if I make AB the subject, so AB is 10 divided by tangent of 40 degrees. That's the first thing. And then let me write it further. So we know that AP plus PB equals to AB. So therefore, we have just found PB. We are now finding AB. We found AB actually. So therefore, the green one AP, that AP equals to AB minus PB. AB minus PB, and then you can write it over here. You can use the calculator value. That's up to you. Perimeter of triangle PBC. So for perimeter of triangle PBC, what do I need? I need PB, which is found. I need BC, which is given. I need PC, which can further be found. This can be found either using Pythagoras. That's one approach. Or maybe I can use cosine. So Pythagoras or cosine, that is better. So therefore, cosine of 20 degrees is 10 divided by PC. Cosine of 20 degrees is 10 divided by PC. Therefore, PC is 10 over cosine of 20 degrees. BC was given, that is 10. PB was found earlier in part 1. So I did not use a calculator, but did all the steps that is necessary in order to solve this. Now, let's move on. I have deviated from this. So let me go to the table of contents and let me give you 1 or 2 questions to try it out. So this is the one I just solved. Let me just write this in 1 page. Make sure your calculator is set to degree mode in case anyone is studying AdMaths. So in AdMaths, you work in angles and radians also. So just a simple question, just asking you to get ready for this. And okay, so I have just written it on 1 page so that you can see it comfortably. And let me stop the recording for right now. Now, this is a paper 2 question again. First, it says in the triangle PQR, RPQ is 18 degrees. That is this one. This angle is 90. This is the hypotenuse. We are interested in PQ. So with respect to 18, PQ is the adjacent side. So therefore, we will write cosine of 18 degrees is PQ divided by 4.5. Therefore, PQ is 4.5 cosine of 18 degrees. And then you get this answer. Second question. Again, a right angle triangle. And we are interested in angle ABC. So let me just mark this line. This is the hypotenuse. And then the blue one is the opposite, depends which angle are we talking about. And this is the adjacent. But if you're talking about ABC, so for ABC, 6 is the opposite. And BC is the adjacent. And 10.2 is the hypotenuse. So we are asking for this, finding this angle. Therefore, sine of ABC, that equals to 6 over 10.2. Therefore, angle ABC is sine inverse of 6 over 10.2. And then you will find this answer. What about this one? This is D is the point on, I think it's the same triangle, right? So this ABC is there, the orange, blue, and red. Let me mark it. So this is the red one. And this is the blue one. This is the orange one. And we are interested in AD. Now, if we have, can we find BC first? This is for 4 mark. So let me first find BC. 10.2 square is equals to BC square plus 6 square. So now I'll be using my calculator. So this is 10.2 into 10.2. That comes out to be 104.04. This is BC square plus 60 plus 36. 6 square is 36. So subtract 36, take the square root. So when you take the square root, this comes out to be 8.248. So BC after the square root is 8.249 after rounding off. This is 4 significant figure because you have to use it for the later part. So work in 4SF. Now, once we have this, now I can use this thing, this green thing, length, that is the hypotenuse. And let me just use this. So this one, if I use the big triangle, I'll again use Pythagoras. I'll find this whole thing. So now 14 point, let me write it at the corner. So let me just shift it over here. This is the small triangle, which is ABC. So this is with respect to the triangle ABC. Now we are working with respect to the big triangle, that is DBC. So big triangle is DBC. And over here, I can write 14.3 square is equals to DC square. I'll find DC, the whole thing square first, plus BC square, that is 8.249 square. That is BC. So now 14.3, first of all, let me square this. So if I square this, this is 68.04. This is DC square plus 68.04. And let me write 14.3. That is 14.3 square. That is, for a second, 14.3 square. That is 204.49. 204.49. So therefore, DC square is 204.49 minus 68.04. Minus 68.04. This comes out to be 136.45. This is 136.45. This is DC square. Therefore, DC is the square root of this. That is 11.68. And this is again 4 significant figures. Now we have the whole thing. We have this thing as 6. So therefore, DA or AD. So AD is 11.68 minus 6. Subtract 6 from it, that is 5.68. So this is 5.68, correct to 3 significant figures. That is the answer for this part. So that is how this question is done.